So good afternoon, everyone. I'm Abhay from EDS Technologies, and I thank you all for taking your time out today and joining our webinar on enhancing driver safety and comfort with advanced economic solution, which is RAMSIS. So before I hand it over to our technical speakers, a brief introduction about our company. So we are the largest technology solutions providers in India with more than 30 years of business transformation experience. We at EDS Technologies, we also help transform businesses by enabling adoption of virtual twin and geospatial analytics, and as well as 3D printing. In fact, we have introduced many technologies like 3D printing, VR, digital manufacturing, etc. for the first time to the Indian customers. We have established ourselves as a trusted partner for more than 2,000 organizations across various industries such as automotive, aerospace, industrial equipment, heavy equipment, defense, mining, and others. We are backed by dedicated regional teams who are reinforced by our domain and functional consultants. We also have strategic alliances with global leaders who are pioneers in their respective technology areas. We have a widespread presence across 11 offices in India, and we aim to be an end-to-end technology solutions provider to our customers. So this is a brief offerings of what all we provide as a company. So we provide the 3D experience platform solutions for 3D modeling, CATIA for 3D modeling, Syndia for engineering simulation, Innovia for enterprise collaboration, Delmia for digital manufacturing. We also provide RAMSIS, which is a software from Numentics for ergonomics simulation, which is all what is today's webinar about. And we also provide a product called QChecker for checking the product data quality. In addition to that, we also provide 3D printing solutions, metal, polymer, and electronics 3D printing solutions. Apart from that, we provide electronic design automation solutions and optical design solutions from Synopsys. And we have mining solutions as well, which we provide from Dassault Systems. And military simulation and training solutions, specifically redirected towards aerospace and defense segments. Next slide, Sushi. So today we are honored and we are very excited to be joined by our customer speaker from Maruti Suzuki, Mr. Deepak Kumar. So Deepak-san holds a master's degree in manufacturing science from IIT Bombay and brings over 14 years of experience in automotive R&D at Maruti Suzuki. His work spans key areas such as R&D, CAD modeling, vehicle layout, benchmarking, and ergonomics. As a head of ergonomics and HMI group at Maruti Suzuki, he leads a nationwide research on driving behavior to inform and improve ergonomic designs in vehicles. So he has also developed standardized methods for evaluating vehicle ergonomics using both digital simulations and physical models to enhance comfort and usability. Deepak-san will be followed by our technical speakers, Mr. Sushil Punaskar. Sushil works as a senior solution consultant at EDS Technologies for specialized applications such as RAMSIS, QChecker, and Kava solution. He has more than 20 years of industrial experience and has worked with many major Indian and European OEMs. In addition to ergonomics, he also specializes in BIW design and development, composites, and carbon fiber BIW design. So we will be having a demonstration of the RAMSIS application as well, which will be done by our next speaker, Mr. Pranay Malevar. Pranay is an applications engineer at EDS Technologies, specializing in digital validation solutions for clients in the automotive and aerospace industries. He supports key processes such as ergonomics evaluation, compliance checks, and design comparison. His expertise includes deployment and support of tools like RAMSIS, Kava, QChecker, and XCompare. Pranay is also responsible for training, installation, and troubleshooting, ensuring seamless integration and effective use of these tools. So now I invite Deepak-san to present his findings, how RAMSIS has been able to help Maruti Suzuki in enhancing driver comfort and safety aspects. He has a short presentation. I'm just handing over to Deepak Sir.
Hello. Thank you, ADS team, for giving me this opportunity to introduce myself and my. I can briefly introduce about the work which we do. So today I will be briefly discussing about the application of RAMSIS in MSIL vehicle design process. First of all, I will be talking about my company, Maruti Suzuki India Limited. As you know, we are the market leader in Indian automotive industry with more than 40% of market share. Our annual sales is 2.2 million cars. We have strong presence in hatchback, sedan, V, vans, LCV. Almost all segments we have presence. As a company, our vision is the leader in the automotive industry, creating customer delight and shareholders' wealth, a pride of India. As an ergonomist, our aim at Maruti Suzuki is to enhance the vehicle ergonomics to provide comfort, safety, and driving experience to the customer.
Deepak Sir, if you can speak a little louder, it will be helpful.
Okay. So, briefly, I am discussing about my responsibilities. So, I am responsible for vehicle ergonomics and HMI group of MSIL R&D. Am I audible enough now?
Yes, sir. Yeah.
Yes, Deepak Sir, please go ahead.
Okay. And my role is to define the ergonomics performance of a vehicle to ensure customer delight and joy of mobility. How we do? By maximizing the interior space and postural comfort and minimizing the physical and mental workload of a user. So while on this page, like we are as an ergonomist in India, we are dealing with a unique challenge. Like we are seventh largest country in the world, around 1.4 billion people from north to south, eastern to western border. The user anthropometry is different, food is different, culture is different, and all this diversity reflects in the behavior of user. And these behaviors affects the driving preferences or driving style of users. The people who are driving in the coastal area will be having different driving preferences than the people driving in the Himalayan region. And apart from this, there is unfortunately there is diversity in the road conditions also. Like there are world-class highways. We have Samriddhi Mahamarg and the in Delhi Mumbai expressways, and there are roads which hardly you can call it as road. They are bunches of the potholes. Then the driving experiences varies. User requirements are different. Day condition. We have beautiful Himalayan roads. Then we have one of the busiest market where we need to drive. There are people who do not follow the rules on the road, and there are animals also in the road that we have to take care of the driving. In expressways, unfortunately. So the visibility, reachability, spaciousness, all this become very much important to take the control, to have sense of commanding feeling in the vehicle. cognitive workload everywhere. If you go outside, you will hardly find user will be using horn. And in India, we had developed horn as a method of communication with the fellow drivers. These are some unique things in Indian context. So, how we will address these diversities? We are making in India, creating for India.
Deepak-san, I think one of the attendees is still telling your voice is very low. Request you to speak a little louder.
So, what we are doing, we are making in India, creating for India, but really it is indigenized or not. Like we have eye-lips, but have we ever talked about Indian eye-lips? We talk about the mannequin AM95, AM50, but whether we have IM95, IM50, IF05, what we are following in MSIL now is to identify the habits, user preferences, quantify it, and integrate in the model development process.
Sushil, I think there is some technical glitch. I think maybe you can take over the presentation.
I think Mr. Deepak-san is facing some kind of network or
Yeah, I'll check with him. You can take over the technical presentation.
So, good afternoon, everyone. Myself, Sushil Punaskar from EDS Technologies, working as Senior Solution Consultant. And we will, next 30 minutes, we will present, we will see how RAMSIS can greatly benefit you in terms of ensuring ergonomics for your vehicles. It can be any vehicle. So let's move ahead. I hope I'm loud and clear. Please confirm.
Yes, Sushil, you can.
Thank you. Thank you. So in next 30 or odd minute, we will see these contents like ergonomics as a key performance attribute, why it should be treated like that. Then we'll see evolution of RAMSIS, how it evolved. Then we'll see some typical use cases of RAMSIS application for different vehicle segments. We'll cover a very broad range of vehicle segments together. We'll see some special and add-on modules in RAMSIS and how they can benefit. Also some global and Indian customer list and brief, if the time permits us, a small overview of RAMSIS application, how it looks, how to work with it, and how does it seem. So that we'll see, and it will be followed by a question and answer session. So let's move on. So ergonomics as a performance attribute, why we have to treat as a performance attribute. For example, RAMSIS is the most comprehensive ergonomic simulation software for the design of vehicles and aircrafts, which if deployed in the vehicle developments from the initial studies may result in a lot of tangible benefits. Like we can come to we can converge the solution quite quicker. We can quicker concept selection we can choose from the many iterations, but thereby we develop shorter development times. We can understand and factor in ergonomic concerns very early in the development process. Thereby, we avoid a lot of surprises in the later stages of development. Then there are, we can save a lot of cost also. Less number of physical assessments will be required. And since we are working with realistic anthropometric data, we don't have to assume any human sizes and proportions because all the three-dimensional digital mannequins will be available at your for the studies. And thereby we improve product ergonomics quality and ensure customer satisfaction while driving the vehicles. So that is the final outcome. So just to correlate why it should be considered as a attribute is we have different performance attributes on the overall vehicle, and these are a list of the big list of attributes. And these attributes we define to ensure that the vehicle perform as intended in all the odd and abuse conditions. So that is any type of condition our vehicle should be able to perform And there we achieve that by defining a lot of attributes. Manufacturing, assembly, service, crashworthiness, durability, NVH, fatigue life, etc. These ensure your vehicle performance in real life conditions. But how do we ensure that the vehicle we are designing is for the people? And people have different requirements inside a cabin. So for that, we have to study each and every activity inside a cabin from ergonomic principles, and thereby we improve our cabin ergonomics and we give a kind of comfortable perception to the mannequin or to the real life people. So thereby RAMSIS comes into picture. So RAMSIS is basically a product of Humanetics, Germany. It's a German-based company. And to see on it's a graph here, very interesting. We have on y-axis, we have this ergonomic quality of cars, and on x-axis, we have the year the vehicle was launched. So if you see before 1960, it was more pre-SAE era, and it was a more 2D dominant era. Then we have a big 30 or 40 odd years where SAE templates and rules and guidelines dominated the whole automotive world, ergonomics world. And then we have post-SAE era where we have do ergonomics in the 3D environment, where RAMSIS comes into picture, apart from some other softwares. But RAMSIS, being the leaders in the scenario, has dominated the market from early 2000 year. So before we have to choose our customer who will be driving our cars or any type of vehicles. So RAMSIS has many different anthropometric databases from different age groups, from different reference years. It has also a secular growth phenomena where there is a database progression which you can choose future mannequins also for your studies. It has also inbuilt bodybuilder module by which you can create your own custom mannequins and save it and use it for your custom studies for that. And let's go ahead. So these are typical use cases, like we have to first define our test sample, who is the population that will be driving our cars. It can start from a smallest female to tallest male, or slimmest male to fattest female, or different of varieties for that. But if you see the right hand image, these are the somatotypes. The same percentile height-wise will vary in different sizes. And we know that it's a real life condition, but for which anthropometry we define or we design our vehicles is a question. So for that, we have to factor in this all ergonomic conditions into vehicle design. And this is all can be possible with RAMSIS.
Uh, like I was saying, make in India, create for India is to identify through various research, quantify it through various tools like BMT, eye tracker, BMT is for body motion tracker, eye tracker, and integrate all these assessment in the model development process. So next I will be going uh, how Ramses and MSIL partnership is going. So we had started using Ramses since 2012. It has helped us to achieve two main objective. Number one was the front loading of ergonomics input in the design. Uh, Here, this is the typical vehicle development cycle where we had quantified the ergonomics requirement, and for every vehicle we had given the targets, like from at advanced stage only, when advanced stage and advanced design is happening. So advanced ergonomics targets we provide, and then the ergonomics check happens. Our aim is to eliminate this physical simulation. Earlier it used to be, and we want to eliminate this physical simulation so that we can overall reduce the vehicle development cycle. Then integrating Indian specific requirement, which I had talked about, that in India there are many unique cases. Day driving conditions, night driving conditions are very challenging in India. There are some customs like turbans. Turbans are can be treated as the part of body because it is not hat, you can remove it. Then there is user habit, how a user interact with the different controls. What are their operability habits, visibility preferences, how he take the judgment on the visibility, and how these attires, like we have lungi common in the southern side, then uh, there are uh, jeans t-shirts, then there is what to say coat pant if people are wearing, then saris, uh, salwar. Every with every attire, the seating notch preference might change. So how we are adopting the making RAMSIS to adopt the Indian conditions for our use is we had done a lot of correlation activities. One is reachability. So whatever we are getting in the RAMSIS, like it is not possible for any software to integrate the user habits or user requirement of any other country. Like RAMSIS is developed in Germany. It is a great software which provides a very good interface. However, when RAMSIS was developed, it will have certain what to say links from the German population. So making it adopt, it is the responsibility of Indian ergonomists. How a user are sitting that I had talked about. So we create leg envelope, catering the complete uh, user catering the user habits and their preferences. Then visibility correlation. So what we are getting in the RAMSIS and what we are getting physically. So what kind of uh, changes we can do in the RAMSIS with which the result I will be getting in RAMSIS and the actual will be same. So these all are we are doing. Which means I had talked about the uh, decision making, the what to say, uh, the education level is different in India. So when we are talking about the Indian specific requirement, there is mental workload point also comes that I had not covered. I don't know means whether before the network interruption, whether I was able to say it or not. I want this point again to emphasize the mental workload is actually very underrated in India. The mental workload, the decision making varies. The horn which we are uh, had developed as a tool to communicate will have a larger impact on our psyche, our temperament. So how we are keeping our means how the user temperaments are changing. The ergonomist should develop the digital screens also as per the natural decision making of a user. For example, like we are developing the VR voice assistants. Uh, so in voice assistant, we now English has also come, but the pronunciation part. I remember in my college days, my professor said, "Write H," and I was confused. I said, "Pardon, sir, what you are saying?" He said again H. I was again confused. Then I write it HATCH, but actually he was meaning H. So from north to south, the pronunciations are different. How we are, as an ergonomist, changing the voice assistant to the user needs. Similar things we have to do in all the aspects, whether it is the physical one or it is the digital one. That we have to think and we have to make the vehicle according to the Indian user requirement, Indian users habit. So this is the content which I wanted to share with you all. So this is all from my side. Thank you very much for giving me the opportunity to share. And these are my contact details. You can reach me out.
Now I would like to hand over back the presentation to Sushil
Yes,
to continue with his technical presentation.
yes, please. I hope my screen is visible and I'm putting in the slideshow now.
Yes.
So we were right on this slide before Deepak San actually came back. So in Ramses, we have inbuilt bodybuilder where you can tweak certain dimensions of the body and save it as a custom mannequin, and you can use it for future studies and ergonomic analysis for your custom-made vehicles. So that is quite inbuilt. There is no separate license, but it is inbuilt. Then we talk about databases. Databases, I mean the anthropometric databases, the population databases, because country by country, nation by nation, people vary in sizes and proportions, and we have to factor in this variation in our analysis. So we choose different mannequins for Indian anthropometry. We have this ARI Size India database, which is quite popular, but it depends upon which is the target country and which is the target market. Based on that, we can choose our databases and we can progress our studies accordingly. To quite decently help the ergonomics engineer, RAMSIS has in place a readily deployable posture models, which can be readily deployed in the vehicle space without much efforts. With just few constraints, we can posture them inside, which will get rid of, which can quite shorter the packaging time of the mannequin inside, what we call it occupant packaging. It can be done extremely quickly in RAMSIS. Otherwise, it takes days and days, and we are never sure that we have correctly positioned the mannequin in space. So that assurance we can get from RAMSIS mannequins. Then with RAMSIS, once it's populated and positioned and packaged inside the vehicle space, we can carry out certain or our intended ergonomic activities that we would perform had this been a physical vehicle. So we can perform the co-driver side glow box unlatching. We can door grab handle pulling, pushing. For different varieties of mannequin, we can try that activity if it's reachable or not. For truck scenarios, we can study the reachabilities because the size apertures are quite big in that location. It's quite big to reach here, and we can compute the maximum reachabilities in RAMSIS so that to know that what are the reachable areas by the mannequin. So these are very important surfaces and envelopes for studies. Then once tactile studies are done, we can start with the vision studies where we can compute the acuity and readability of the characteristics on the instrument cluster, whether they are readable by the certain group of people or not. That readability studies we can perform in RAMSIS. Cluster steering wheel obstruction onto the cluster or dashboard can be effectively studied with RAMSIS. The blind spot or the apilar obscuration and blind spot analysis we can do in RAMSIS. It's very much possible. You see here the hub of the steering wheel is quite blocking the main area or most of the area of the cluster, so which is not a good condition. It becomes very worst when we have tilt and telescopic mechanism in the steering wheel. So we have to factor in that also in the studies. We can do that with RAMSIS. Then there are some indirect vision studies, for example, the ORVM studies. We can see the rear world imprinted into the mirror glass here. What is the real life condition? Then for truck where the visibility is more compromised, we can study with the mirror positions and the curvatures and see whether the near visibility is quite good and there is no blockage from the vehicle structure toward the visibility. In RAMSIS, we can study the driving posture in terms of discomfort. For example, this is the most occupied condition inside a cabin of the driver. So in this condition, he has to be quite nicely comfortable. That we can analyze through RAMSIS. There is a kind of a spider chart that is available in RAMSIS, which gives you a good idea on his principal joint locations in his body, how much is the discomfort level on 0 to 1 scale that we can study. So if example, any spike goes around the back region, that means his spine is not in the right, either the torso angle is bad or it's too more or too less. So that we can confirm from this. So this is a job of a typical ergonomic engineer in that way. But this graph can help overall to understand the driving posture, which has to be comfortable by default. Then RAMSIS also has a automatic mannequin and posturing, we can say. We can place n number of mannequins inside and study their behaviors. And by this way, automatic posturing, very quickly we can position the mannequin. This is a very slow simulation. So it's a driver getting positioned and then getting moved into the cabin space automatically. This can be performed very quickly in RAMSIS. There is no big efforts and there is no big, I will say, intelligence also required here. So this is called automatic posturing, which is possible for driver and for rest of the passengers also. Joint capacity again is one of the best feature of RAMSIS. Every joint in body has some usable range of motion, and there is certain part of the range which is not usable. So as and when we move towards the extremes of the usable range, then we feel certain discomfort. That is also one of the parameters by which we can study the discomfort. So for example, here the leg region is being studied, and definitely his hip region is in the bad shape, definitely. So this we have to analyze and solve upon this condition, but this joint capacity helps a lot in terms of analysis. Again, you can compute the maximum forces that a mannequin can be a small female or a tall male, any variety of population. So RAMSIS can give you how much he or she can, in this position, generate the force at his palm, so that what force level she can generate out of his body strength. So this can be studied, and it can be, the objective values are available. This can be a good value to further engineer maybe the door bushes or the hinge axis or hinge separations, etc. Yeah, it's again the same slide, I think. Let's move ahead. So again, by default, RAMSIS has been provided with a motion recorder by which any study that you do, you can record the motion in terms of some kind of AVI file, which you can keep for your I will say a record, and for maybe in terms of if you happen to go for in some management meetings and justify your design selection, then you can produce these recorded movie files as a proof of your concept selection theme, and then that can be a good, your concepts can quickly get selected and you can move on for the further developments. Once mannequin is seated, this can be performed in the very early phases where there is no cast. We have just R point and the vehicle outline. But then we can populate the whole cabin space, which is virtual at the moment, with many number of test population, which will eventually drive our vehicles. And we can study the overall layout from these population databases. Again, there is no need to technically use the SAE-J standard for headroom calculations, but since the realistic head population is there, we can set our roof line quite nicely, and not too much height, not too much low, but optimally we can set some good enough clearance around the head, and then we can make that roof line accordingly. But from that, we can also do some cabin interior activities like cup holder holding and some knobs pressing, etc. That everything is possible. The reach, the grip location, maybe some out of cabin activities like cargo loading, then leaning, and also the trunk top opening or the reaching the latch here. This all can be performed, which are non-driving activities, I will say. But certain things are these things can be possible with RAMSIS. I think this we have already studied in previous slide. Regarding commercial vehicles, we have some posture models that are readily available. So in commercial vehicle, we have the lower berth and the upper berth, where the co-passenger usually sleeps and the driver drives the vehicle, and they change the roles accordingly. So these ready-made posture models are available, by which you can see their reachabilities, visibilities. If some convenience factors has to be given around them, we can think of that details as well with the help of these posture models. Again, these are related to truck driver visions. I think we have looked at this slide before, but we can simulate our mirror vision accordingly. The wide angle mirror and the proximity mirrors on the front and the side with the help of RAMSIS analysis. RAMSIS is also extensively used globally also, and Indian scenario also for two-wheeler ergonomics. Two-wheeler ergonomics is actually a very kind of awkward due to the inherent vehicle structure, because there is a negative torso here angle. The most convenient is the backward sloping, but this negative torso inclination gives a lot of stress on his spinal column here, which is all the time actually is in the stress zone only. So we can study this ergonomic triangle, what is kind of, I will say, a good indication of the driving posture, and any small change in all the three hard points greatly deteriorates or greatly benefits the overall driving posture. So that we can study through RAMSIS. BMW is actually a global customer of RAMSIS in Europe. And once mannequin is postured equally like in car, we can also posture them equally on the vehicle, the two-wheeler and bike and scooter space also. And once it's populated, we can study their thumb reachability, finger grasping, and then thumb finger reachabilities. By that, we can set the nominal position of the clutch lever also. Once we know the reachability of the fingers, yeah. Apart from that, tactile studies, we can do some vision studies also, same like in car. The forward visibility, now this is the tallest male, but the shroud on the cluster can be a nuisance for him, so that due to the higher eye points, he may not be able to see certain portion of the cluster here, which is terrible. So we have to factor in such conditions and solve this ergonomic issue actually before we uh, set the design freezes and etc. In today's crowded situations in all the metros or in many of the cities, we have to always look from this ground reachability for bike riders. We drive very closely each other and very close to each other. So quite a lot of times there's a situation where we keep one leg on the ground, but this has to be studied, and we have to then come out to optimal saddle height, which is a seat height from the ground. So too much saddle height will create the shorter people discomfort, and too much lower will create the taller people discomfort. So we have to choose very intelligently, but these all studies can be done in RAMSIS, and we can come to a very optimal saddle height where neither he is happy or neither he is discomforted. Yeah. Apart from that, some indirect studies can also be done on two-wheeler. For example, this is a range of 3 different mannequins, male and 2 female. 1 female and 2 male are looking at the mirror here, and they have this visibility cone. So these cones can be studied. By that, we can make a decision whether if we increase the mirror by suppose 5 millimeter more, how much delta gain we are getting. Is it too big? And if that is quite a big one, then we can justify that decision to create an enhanced vision uh, uh, help to the riders, which is required actually on road. RAMSIS also has a two-wheeler motorbike library, which we can put on the mannequin with realistic appearances and the clothings and uh, jackets and helmets and the shoes and trousers, so that we give a realistic feel. And apart from that, they also put on some packaging clearances around the mannequin, by which we can study our vehicle structure and improve the scenarios. So in a click of a second, we can just toggle between the two appearances here, and which is the most worst. We can also choose between the helmets here. Yeah. RAMSIS, as I said, aircraft industry also equally uses RAMSIS globally also. And in India also, we have Indian customers who use RAMSIS for their cockpit engineering and cockpit ergonomics. We can position pilot, co-pilot into the vehicle space, digital cockpit here, and we can see their clearances and articulations and reachability curves, visibility curves, etc. For example, this is a passenger looking out from the knob here. This can be not just for the cockpit, but for the passenger cabin space also. We can study each and every activity. For example, the knob here is quite feels quite tall for certain short females, which is an ergonomic concern that has to be sorted out properly. Yeah, we can position this is a typical populated mannequin inside a cockpit here, but any small control can be there. We can study the reachability, grabbing, and while operation, whether the hand is clashing with some other hardware or not. Is there any ample clearance between that? All these studies can be done and we can improve upon. Otherwise, these will be a surprising elements once the vehicle is made out, once the aircraft is in production. Apart from that, direct visibility can also be performed. We can perform some direct vision. This road, the ground visibility, just like in car, we do that. But apart from that, reflection studies can also be done. It's quite a cluttered cockpit region here. So all controls can technically reflect onto the windshield here, which is not a good scenario. And we can position, once we study them, we can position them, the controls in such a way that they at least go out of the most visible zone on the windshield. And we can do some intelligent engineering here while packaging. Just like aircraft, we also have some use cases for tractors globally and also in Indian scenario. A lot of OEMs use tractors, RAMSIS for tractor ergonomics. It's very pathetic for tractors because the very less emphasis is given to the ergonomics and the comfort of the operator here. The seat, if you see, the seat is not totally covering the back region because the driver is not meant for comfort. He's meant to work. So that is, but at least we can do certain things, that we can make certain improvements in his cabin so that he at least feels some comfort operating the levers, holding the steering wheel, then operating the ABC controls here, operating some other controls around the way, operator here. We can study through RAMSIS and at least give some additional comfort to the tractor operators in this way. We can study the reachability curves, as we say, and package intelligently. These are the three reachability curves that we have, and we have to package the most. So this is the most inward. So anything that we have to package, which needs to be touchable, has to be packaged inside this red curve. That is the decisions we can take through RAMSIS, having these reachability envelopes. Now, this is looking back condition is most frequent in farms and for tractor industry. So we can simulate such conditions and we can make the mannequin look sideways, rearwards, or maybe downways, and see the conditions of what he's able to see. So certain real life conditions can be simulated through RAMSIS. So this is a RAMSIS study that was a part of our project, and this is a real life scenario here. So we can technically simulate the near real life conditions in RAMSIS. Also, a 360-degree visibility blind spot analysis can be done. We can analyze the blind spots around the vehicle space and analyze the situations here. Same like that, we can also study their effort values in this areas. It is too high, too low. and we can improve upon maybe some other way the engineering around the door engineering. Regarding earth moving equipments, we have certain use cases of RAMSIS where there is a mirror here, maybe a part of regulation, but then it has to be unobstructed vision. He should be able to see that very clearly, which is this view. But we have no idea unless we simulate that in the RAMSIS, so that maybe this kind of a vehicle structure can go across it and block the vision. We have to avoid such situations and provide a very hindrance-free visibility to the driver. Again, this VTC, what we call vision test circles in tractor industry or earth moving industry, we can do it. Yeah, can study that. Yeah. Ingress egress can be studied quite easily with the RAMSIS here. Yeah. Not also for locomotive industry, there are a lot of global OEMs who are rolling stock industry and metro and train coaches. They use RAMSIS for their ergonomic analysis because the cabin space and the driver station are equipped with fully filled with people, the real people. So we have to simulate that quite critically, and we will come out with. I'm sure we can come out with a lot of interesting studies if some OEM comes out with some proposal like we have to study our cabin with the help of RAMSIS. We are more than happy to assist you in that, because I'm sure we can find some very good insights into it with the RAMSIS. Yeah. So RAMSIS, again, there is a big part, I think, for the seating design. So we can technically fit our seats. We can make a man to the mannequin to seating foam interactions quite in a decent way. There is a module in RAMSIS called seating design, by which you can engineer your seat contours and foam bolster sizes, etc. Having known the population sizes that will possibly drive the vehicle, so we can engineer your seating contours and the thigh exit lines, the usable headrest height adjustment, etc. Yeah, this is thigh exit line, which we can study. Too much thigh exit, too much thigh support, and too less thigh supports, all are bad. We have to have optimal thigh support that we can study with the help of RAMSIS. Again, we can study the usable height adjustments of the headrest up and down, and also the contour of the headrest also. Apart from RAMSIS, is also seatbelt simulation software so can be studied. Seatbelt simulation can be studied. We can populate RAMSIS mannequin and study the belt routing over it. Also, we can study the belt routing over the certification devices called EBTD. And apart from that, a lot of crash dummies like Hybrid and Thor and child dummies can be studied the routing along with the help of RAMSIS. Yeah. So RAMSIS, while simulating, gives you a kind of a belt routing generation, and it also gives you kind of a shoulder scale where it reflects the bone here, over which the belt should route technically, and too much closer to the neck is dangerous, and too much away from the neck is also dangerous. So we have to route the belt in certain way that it routes through midway of the shoulder scale, that we can study, and we can then position our anchorages accordingly. Yeah, second row belt, I will say second row also can be studied. The unbelted situations we can study, and also the hardware here, the buckle here can be studied because it can protrude into the human flesh muscles. So we can have to package it very correctly and intelligently. So this can be studied with the help of RAMSIS. Yeah. I think there's a last but not least, we have I think the last slide. Automatic ingress. So ingress egress, it's a very critical function in vehicle ergonomics, where most of the perception of the mannequin is set. So in RAMSIS, we can study the mannequin ingress egress quite automatically in RAMSIS. There is a new module here by which you can simulate the complete population ingress egress into the vehicle space, and you can study their joint angles, discomforts, clash and clearances, and the overall discomfort that they might be feeling during the whole ingress action. So this is a typical passenger car ingress egress. Then we have a commercial vehicle, which is equally used. Then I will play some video where we have different door openings angles here, and each mannequin will take intelligently its own decided ingress path to get inside the vehicle, and by that we can select their study their behavior, their joint angles, discomforts, and also set up the optimum door opening angle. This again, the passenger car from the front side. Yeah, so it works on the collision avoidance here. Yeah, so whatever hardware we give it to the floor and the sill area and the roof line, the mannequin respects that hardware, and it avoids that, and it tries to get inside the vehicle. So it's called a vehicle collision avoidance strategy. It's a classic example of the commercial vehicle ingress egress, by which we can study the joint angles here over the time frame as and when the mannequin is getting inside the cabin. It's a commercial vehicle with these reflecting the footsteps of the vehicle. Let's move ahead. Okay, I think that was the last slide from my side. I think I slightly over crossed the time, but it was required. Then we have global and Indian customers. So you see all big brands are here. It's very popular amongst the automotive industry around the world. Also, bus and truck industry, two-wheeler, industrial vehicles, and aviation make use of RAMSIS for their day in, day out ergonomic analysis. In RAMSIS available on 3 integrated CAD platforms and 1 native CAD platform. It's their indigenously designed platform that's called RAMSIS Standalone. And for integrated platforms, we have this CATIA V5 integrated RAMSIS, 3D Experience CATIA integrated RAMSIS, and Siemens NX integrated RAMSIS. Technically, there is no difference capability-wise. It's just the matter of platform integration.
Yeah. So first of all, I would like to thank Deepak San for taking his time out and joining for our webinar. His insights on how they use RAMSIS at Maruti Suzuki was very insightful for us, and I'm sure the audience also benefited from the presentation. We do have some couple of queries, Deepak San, which we will share with you separately. Maybe you can answer that to us, and we can convey the same to the customer. I would like to also thank Sushil for delivering a very informative technical presentation. So I'm sure this was very helpful to our audience. I would like to thank the audience as well for taking their time out and joining us for this session. I know there are some queries which we have unanswered. We'll reach out to you separately and answer them. In case of any additional queries which you would be having, you can always connect with us. Our details are displayed on the screen right now. You can reach out to us at any time to the displayed credentials, and we'll be happy to address your queries. So please do keep an eye out for our upcoming seminars and webinars. So you can follow us on our social media for the same. Thank you once again, Deepak San, Sushil, and all the audience for joining us today. See you at the next session.